In the previous section, we looked at being able to plot numbers on a number line and basically just one-dimensional values. So in this video, we're going to look at two-dimensional values, and we're going to take a look at the Cartesian plane. And the Cartesian plane has two axes. So the horizontal axis is going to be the x-axis. So this is our x-axis, and this is in the x-positive direction, and this is the x-negative direction. And then we have the y-axis. So this is the y-positive. So anytime we go up, it's the y positive. Anytime that we go down is y negative. So the x-axis and y-axis are going to be basically going to be our points of reference, and at the very center is going to be the origin. Okay, so our origin is right there, and we have four quadrants in the Cartesian plane. All right, so when we kind of work with the Cartesian plane, we call this quadrant 1. Okay, so the one that's in the upper right, and quadrant 2, quadrant 3, and quadrant 4 follow suit. And if you think of like a counterclockwise, that's a way to remember which quadrant is which, as long as you remember that the upper right hand is quadrant 1, and then you just make like a C, if you would, so like this C for counterclockwise, and that'll remind you as to which quadrant is which. Now, most of the time, we're looking for specific points within the Cartesian plane, and those are going to be called ordered pairs. So we have a slew of ordered pairs right here that we're going to work with. Every ordered pair is of the fashion that we go in the x direction first and then the y direction second. So this is going to be our x coordinate, and this is going to be our y coordinate. All right. And so our job is to be able to plot on a Cartesian plane these x coordinates and y coordinates. So let's take a look at how to do that. So our first point that we're looking at is 3, 4. All right, so I'm going to blow this up just a little bit. And so to plot the point 3, 4, what we would do is we would move to the right 3 units. So we go 1, 2, 3. And usually what we do is we wouldn't mark those off, but just so because I'm talking and I can't really show you anything else. And then what we would do is we would move up 4 units. So we move up 1, 2, 3, 4. And this right here is going to be our point 3, 4 on the Cartesian plane. So this is point A. And clearly point A lives in quadrant 1. All right, so if we were to name which quadrant it is, it's going to be in quadrant 1. Now, the second point that we have is negative 2, 1. So I'm going to move to the left 2, and then I'm going to move up 1. All right, so this is going to be our point B. All right, and clearly that's going to fall in quadrant 2. All right, so that's quadrant 2. We have the point 7, negative 3. So we move to the right 7 units. And then we move down 3. So we move 1, 2, 3. And right here, this is going to be C, which is going to be in quadrant 4. Okay, so you might remember that we had like that C where we just drew points. Okay, so this is going to be in quadrant 4. Right. And then finally, the point 4, negative 4, negative 2. We would move to the left 4, and then we would move down 2. All right, so right here, this is our point negative 4, negative 2. So that's D, and that's going to live in quadrant 3. All right, so pretty easy. All right, now what if it doesn't live in a quadrant? Okay, so let's take a look at this point 0, 5. So what we would do is we would move 0 left or right, and then we would just move up 5 units. 1, 2, 3, 4, 5. And so that would be right here. And so that's point E. And if it doesn't live in a quadrant, what we're going to say is that it falls on the axis. In this case, it actually falls on the y-axis. Remember, if we go up, that's the y positive. So that's going to fall on the y-axis since it's not in a quadrant. And then finally, negative 1, 0, we would just move back or to the left 1 unit in the x negative direction. That's point F. And so that's going to fall on the x-axis. All right, so that's how we plot coordinates on the Cartesian plane, and that's going to be the anatomy of the Cartesian plane. Now, one other thing that we want to make sure of is that we can use the Cartesian plane to show geometrically a relationship between two variables. And that's going to be how we graph these things. All right, so what we're going to do is we're just going to create a table of values. And what that's going to do is that's going to tell us that what the x value and the y value is going to be. And so what we're going to do is we're going to substitute values into the independent variable. In other words, in this case, if we're looking at this expression or this equation y equals x minus 2, y is dependent on x because as we plug in values for x, y is going to get larger or smaller depending on those values, right? And so with our table of values, we're just going to go ahead and we're just going to create ordered pairs, all right? And I'm assuming a lot of you guys have probably found or created a Cartesian plane before, and you plotted points and you plotted expressions on there or equations, but I just want to make sure that everybody's okay with this. So in this exercise, what we're going to do is we're going to complete a table of values for this. We're going to plot the points, and then we're going to sketch the graph. All right, so we have this y equals x minus 2. And this kind of goes back to what we did earlier in the previous video, where we created values and then substituted those values in. All right, so here's our table of values. So we have x and we have y. Now, I'm going to make up values for x, all right? And what I'm going to do is I'm going to say something like -3, -2, -1, 0, 1, 2, and 3. All right. And what I'm going to do is I'm going to substitute -3 back in for x. All right. So when x is -3, y is going to be equal to -3 minus 2 or -5. And then y equals -2 minus 2 by substituting -2 back in for x. That's going to be a -4. And we can kind of see this pattern as to what's going to go on. So if y was equal to -1 minus 2, that's going to be -3. And it just looks like that we keep descending by 1 each time. All right, now I'm going to do this each time just because it's the first time we've done this. So it's going to be -2. And if we substitute 1 back in, 1 minus 2 is -1. And then if we substitute 2 back in, that's 0. And then finally, if we substitute 3 back in, that's going to be 1. All right. Now, each of these are ordered pairs. All right. So we can kind of think of each of these as an ordered pair that's going to lie somewhere on the Cartesian plane. And then what we're going to do is we're just going to connect those points to represent all values that fall in there. All right. Because these are only integer values that we use out of convenience. We could certainly plug in something like 7.6 or 4.3, but that just might be a little more difficult to plot. All right. So here's our points. So we're going to plot -3, -5. So -3, -5, as we looked at before, falls right about here. And then we're going to plot -2, -4. And then we're going to plot -1, -3. And then we have 0, -2. And then we have 1, -1. And then we have 2, 0. So these are our points. And what we're going to do is we're just going to connect these. And it looks like it formulates a line. Now, we're not just going to stop, okay, because there are an infinite number of values that fall on this line. All right, we're just plotting a few of them. Okay, so that's how we plot these. One thing to notice is that we have a couple points where it crosses the axis or the axes. So we have a point here that crosses the axis. So we have a point here that crosses the axis. We're going to see a little bit later that those are intercepts. So this would be an x-intercept. And we would see right here that this is a y-intercept. Right? So those are the points that are going to cross at an axis. And I want you to notice that the intercepts, we notice that for the y-intercept, because remember, this is the point 0, -2, all right, we know that the x value is 0. And again, we're going to cover this a little bit later in more detail. And for the x-intercept, which is at the point 0, 2, all right, we notice that, or I'm sorry, 2, 0, sorry, put that backwards, right? That's going to be where the y value is equal to 0. Okay, so pretty cool that we can go ahead and graph these and that we can also go through and identify these x and y intercepts from the graph. Okay, so we're going to go ahead and plot some more of these sorts of relationships in two variables, and we're going to take a look at the different sorts of relationships in two variables in subsequent videos. But for now, hopefully this makes sense as to how to plot on a Cartesian plane and also to graph equations on a Cartesian plane as well.